right, continuing on with our look at sequences and series, our last section here with sequence and series. So we'll be having a quiz coming up soon on this material. In section 8.2, we talked specifically about an arithmetic sequence or series where you are always adding the same number to get to the next term. And those were some of the ones you still saw in section 8.1. Today we're going to talk about what's called a geometric sequence or series. Geometric meaning that there's a ratio between consecutive terms. So you're always multiplying by the same number to get to the next term. And that establishes a ratio. So for arithmetic, you had a difference. You are always adding the same number to get to the next term. In a geometric, there's a ratio, and you're always multiplying by the same number to get to the next term. So now we have the ability to ask you to decide whether the sequence is arithmetic, geometric, or neither. This is very much like what quiz questions will be. And this is the first step that you'll always have to establish because you need to know which formulas you can use and which, even if you're going to do it by inspection, what should be your methodology. So to try to decide if it's arithmetic, geometric, or neither, you're going to ask yourself, is there a common difference? Is there a constant ratio? Or is there just no pattern? Going through these pretty quickly, it looks like this one, you are multiplying by 3 each time. So you could say it is geometric, and you could say the ratio is positive 3. This second one looks like it's being, I guess it looks like it's being divided by 2 each time. 24 divided by 2, 12 divided by 2, 6 divided by 2. Yeah, it certainly looks like it's being divided by 2, but again, you never want to ask yourself what is it being divided by. You want to ask yourself what is it being multiplied by, and that was a constant, or so you could still say it's geometric, you just want to make sure you say the ratio is 1/2. If it's getting smaller, obviously your ratio is going to be a fraction. Here, let's see, 5 to 10 to 15 to 10 to 5, it looks like they're subtracting 5 each time. So again, that's more like an arithmetic where the difference is a -5. Moving over here, looks 2, 4, 8, 16, 32, but there's alternating between positive and negative. So we are multiplying by -2 each time, it looks like. So you could say it's geometric with a ratio of -2. So anytime you see a series kind of bouncing back or a sequence bouncing back and forth between positive and negative, that's probably a pretty good hint that it has a ratio that is a negative. That's the only way it's going to bounce back and forth. Let's see here, 1 to 5 to 13, doesn't really look like, you're certainly not multiplying by anything. You're adding 4, then 8, then 12, then, okay, there is a pattern, but it's not where you're adding the exact same number each time. This one would just have to be a neither, even though you could probably predict what the next terms are. And this last one, I think that's an easy one from the previous section where it looks like it's arithmetic. You're adding 4 each time, so your difference would be, what do we say, 4. Okay. So being able to identify if it's arithmetic, geometric, or neither is obviously worthwhile in terms of getting some points on quizzes and tests, but it's also more important because if you establish it's geometric or if you establish it's arithmetic, that's going to tell you which formulas you can use. Now geometric is obviously going to be a little harder just because multiplication is harder than addition. The terms are going to grow a lot faster, which means that your answers could involve using a calculator. It's one of those things with testing for myself. I have to make it either small enough where you could figure it out without a calculator, or I have to let you use a calculator. And clearly, since you're at home, you're probably going to use a calculator anyway, so we'll talk about that. But let's see if we can establish a pattern here and see if we can come up with a nth term rule like we did with arithmetic. So the first term is just 3. The second term is 3 times 2. The third term is 3 times 2 twice, so times 2 squared. The third term is, again, starts with 3, and then you multiply by 3, 1, 2, 3 times. So, I'm sorry, 2 3 times. So it certainly looks like it kind of has that same pattern as arithmetic, except that you're not adding on differences, you're multiplying by a certain number of ratios. If we kind of generalize this, I think we can say it's the first term times 2, which was the ratio here, right? We were multiplying by 2, so let's say ratio, and then it's always going to be to the n minus 1 power. Again, kind of like it was n minus 1 differences when we were doing arithmetic, you're going to use n minus 1 ratios to get from the first term to whatever term you're looking at. So again, to get from the fourth term, it looks like we did, to get the fourth term, we took the ratio, we did 3 of the ratios times the first term. To get to the third term, we did 2 of the ratios times the first term. So this looks good, and this is formula number 3, of which will eventually be 5. Formulas that you'll be working with in this section. And again, it certainly is a good way to do it. So if I was doing this particular problem, I would say the nth term is the first term times the ratio to the n minus 1. So the nth term in this problem was 3 times the ratio, which is 2 to the n minus 1. And that would give it to me. I would be able to find any term I wanted to. Obviously, if I wanted to find the 10th or the 50th term, raising this 2 up to a high power is going to make a large number, and you probably want to use your calculator for that. This, compared to what we were doing in Section 8.1, we did have geometric sequences in Section 8.1, and we were doing them without knowing what the rule was. And if you remember, we kind of said something like this. We said, well, we can see that the multiplication factor is 2, so we said, let's involve a 2 to the n. And we kind of said, let's try that. And obviously 2 to the first was not 3, 2 to the second was not 4. And we kind of made adjustments to it. It wasn't nearly as easy as with arithmetic. So in this case, we could say, all right, well, let's start with a 3 and then start multiplying by 2's. Okay, start with a 3 and then start multiplying by 2's. But if you do this, the very first term would be 3 times 2 if you put in a 1. So that's why this adjusts it a little bit, makes it work. I'm of the type that says that with arithmetic, I really like to go old school and do it by inspection, but with geometric, I actually think the formula is just as good, if not better, than trying to use your old school way of doing it by inspection. Just because of the nature of the multiplication and how big it can get. So let's do a couple examples. We can try it both ways if you want, but I think you're going to find using the nth term rule for a geometric is probably easier. So if I wanted to do this one, I would just say, first of all, establish that it is geometric. Well, it looks like you're multiplying by -3 each time. So the nth term is going to be the first term, which is 1, times the ratio, which is -3 to the n minus 1 power. And obviously the 1's not really necessary here, so you could say that it's just -3 to the n minus 1 power. And that could give you any term you wanted. You could find the 50th term if you wanted to. You could find the 10th term. You just have to plug in 4n. Again, you're probably going to use your calculator to do that. If I was doing it by inspection, I'm not sure I could do it any quicker. I'd still be trying to figure out -3 is the ratio that I established, so I put it as a base to the nth power, and then maybe try an adjustment factor. You know, if I was doing it old school, I'd maybe say, all right, let's try -3 to the nth power, and I would say, well, that works, except -3 to the first power is -3, and that's actually that term. So maybe I could multiply it by 1/3 to see if that works. 1/3, so -3 times 1/3, that would give me a -1. So you can see why it's a little harder to do these by inspection. Too much adjustment going on when you have a really easy formula to do it with geometric. And again, just take your first term, multiply by your ratio, and raise it to the -1 n minus 1 power, just to make sure you're 1 behind, because you want to start with the first term and then start multiplying by the ratios to get to the second, third. And again, if the 1, or if you want to simplify it all, you could just say it's -3 to the n minus 1 power. There could be other answers, you know, I will often get multiple answers on quizzes and tests, and I have to check them all because this is just one way to write the nth term. Maybe you have something slightly different where you have an n power here and you made some adjustment on it, or maybe you did 3 to the n minus 1, then you put a -1 inside of parentheses. There's a lot of different ways to do it. But again, if you want to kind of be straightforward about it, just take the first term, multiply by the ratio. Now, again, you're dividing by 2 this time, but don't be tempted to put in 2 as your ratio. Put in 1/2 as your ratio to the n minus 1 power. Again, a common question is, you know, find the 10th term, find the 50th term. With geometric, I can't make it too big if we're going to say non-calculator, but that's why with geometric we often say, go ahead and use a calculator. If I asked you for the 20th term here, you're obviously going to have to raise -3 to the 19th power. That's not something I would expect you to do without the aid of a calculator. Which brings us to finding the sum. Excuse me. Unlike finding the sum of an arithmetic, finding the sum of a geometric, I can't give you any great example to help you appreciate or understand the formula. Okay, so this is one of those times where I'm just going to say, here is the formula for finding the sum of a geometric series. Okay, so this is formula number 4 that you would be trying to either memorize or write down and use as a note card for finding the sum of a geometric series. Again, obviously a little more complicated. You can see it's geometric because it's got the ratio involved. Clearly going to be a little more difficult to evaluate, but again, the calculator is going to come into play here. So let's say I wanted to find the sum of the first 20 terms. Okay, I wanted to take the first 20 terms here and sum them up. Well, that would mean we turn this into a series by putting pluses in there. We would need to know what the first term is. We need to know what the ratio is, and luckily we have both of those. We don't know the 20th term. We don't need the 20th term like we did in arithmetic. So we could say the sum of 20 terms is the first term 3, 1 minus the ratio, which we better establish as 2, to the 20th power over 1 minus the ratio. And it's right here where you can see this is going to be a pretty large number, and it's going to be pretty difficult to do without the aid of a calculator. So maybe try to do as much as you can without a calculator. The less you have to enter in, the better. So for example, this denominator is -1, so 3 divided by a -1 is -3. And then maybe just enter this into your calculator. And we can do that together. Where's my calculator? And again, just enter as it looks. So you could say -3, parentheses, 1 minus 2 to the 20th power. Wow, big number. Okay, you can see why this would be pretty difficult to do. 3,145,725. Okay, there's no way I can expect you to do that without the aid of a calculator. The other option you have, and it's the same option we had when we were doing arithmetic, is you could try to put this into sigma notation and then just use your calculator to do it. And it's not as hard as it seems, because you're going to find the sum of the 20 terms of this geometric series, and you know that the way to produce it is to do the first term times 2 to the n minus 1. Now maybe for your calculator purposes, I'll change our index to an x. That way it makes sense when we enter it into our calculator. So again, if you remember from before, we would hit the math button and we would go down to option 10, which is the summation, and then put in x and start from 1 and go to 20, and then put in what? 3 times 2 raised to the x minus 1 power, and hit enter, and lo and behold, you get the exact same answer of 3,145,725. Okay? So again, even though we only asked for 20 terms, the answer gets huge, and that's going to happen, especially when the ratio is bigger than 1. If the ratio was smaller than 1, you could see that you'd probably start getting some fractions and decimals involved, and that would make the answer pretty ugly as well. So imagine in section 8.3 you'll be using your calculator a lot more than you were in the previous sections to do things like finding the sum of a geometric series. And there's really no way to avoid that. It's not like you're cheating by using your calculator. That's what everybody would do. Okay? All right, so that's most of section 8.3. We'll come back with one last video to kind of wrap up section 8.3, and then we'll talk about a quiz. And while I'm on that topic, I'm going to post the notes as well for sections 8.1 through 8.3. And again, those notes are from a past student, but you can see a lot of things in those notes about practice quizzes that we did in class to kind of get ready for on a daily basis. Please read those over. Obviously, make sure you understand it is a former student that took those notes, and so there could be some errors, but generally speaking, pretty good. So you've got a lot of practice problems in there as well. Okay?